Have you ever wondered how innovators turn abstract ideas into tangible realities? This is where the enigma of prototyping comes into play. Prototyping is a crucial step in the design and creative process that breathes life into ideas, transforming them into real-world products. It's like a magic wand that brings imagination to life. Delving briefly into its historical evolution, prototyping has been an integral part of design and engineering since time immemorial. From the creation of simple mock-ups for ancient architectural marvels to the development of complex, functional models for modern-day technological advancements, prototyping has been a constant. It's the common thread that weaves through various fields, be it technology, automotive, fashion, or even space exploration. Prototyping, in essence, is the bridge that carries ideas from the realm of imagination to the tangible world. It's the translator that turns the language of innovation into a reality we can touch, see, and experience. Prototyping isn't a one-size-fits-all process. It's a spectrum ranging from simple sketches to intricate, fully functional models. Each type of prototype serves a unique purpose and is used at different stages of the design process. At one end of the spectrum, we have low-fidelity prototypes. These are basic, rudimentary models that are often quick and cheap to produce. They're like the rough drafts of the design world, used to visualize initial concepts and ideas. Think of a sketch on a napkin or a cardboard mock-up. While they may not be pretty, low-fidelity prototypes are a powerful tool for brainstorming and early-stage feedback. On the other end of the spectrum, we have high-fidelity prototypes. These are detailed, interactive models that closely resemble the final product. They're used in later stages of the design process when the basic concept has been refined and it's time to test functionality and user experience. High-fidelity prototypes can be time-consuming and costly to produce, but they provide invaluable insights into how the final product will look and feel. Now, let's talk about digital and physical prototypes. A digital prototype is a computer-generated model, created using software like computer-aided design or CAD. These are useful for visualizing complex designs, simulating functionality, and making quick alterations. Physical prototypes, on the other hand, are tangible models that you can touch and interact with. They're particularly beneficial for testing ergonomics and spatial relationships. Whether you're using a low-fidelity or high-fidelity prototype, a digital or physical model, each type of prototype has its own strengths and is best suited to a particular stage of the design process. Low-fidelity prototypes are great for brainstorming and gathering initial feedback, while high-fidelity prototypes are ideal for detailed user testing and final design tweaks. Digital prototypes are perfect for visualizing complex designs and simulating performance, while physical prototypes allow for real-world interaction and ergonomic testing. The type of prototype used varies depending on the stage of the creative process and the specific needs of the project. So the next time you're embarking on a design project, remember the prototyping spectrum and choose the right prototype for your needs. Prototyping isn't just about creating a physical model, it's a catalyst for innovation. Imagine an artist with a blank canvas. The initial sketches, the rough outlines, these are the prototypes of the final painting. They act as a springboard, a starting point, sparking creativity and helping to visualize the end goal. In the world of design and engineering, prototypes are akin to these initial sketches. They are instrumental in the ideation and exploration phase of any project. They stimulate brainstorming, pushing the boundaries of what's possible, and guiding the creative process. Think of prototyping as a creative playground. It's a space where designers and engineers can experiment, play around with ideas, and see how they translate into the physical world. The beauty of prototyping is that it allows for trial and error, for learning from mistakes, and for continual refinement. But prototypes aren't just tools for the creators. They play a pivotal role in communicating ideas and intentions to stakeholders, clients, and team members. A prototype can convey a concept more effectively than any report or presentation ever could. It's tangible, it's interactive, and it brings an idea to life. In this sense, prototypes act as a universal language. They bridge the gap between the technical and the non-technical, between the creator and the user. They facilitate dialogue and foster a shared understanding, and let's not forget the role of prototypes in fostering collaboration. They invite feedback, encourage involvement, and create a sense of ownership among all those involved. In a way, a prototype is the physical manifestation of a team's collective creativity. So when we talk about prototyping, we're not just talking about a step in the design process. We're talking about a tool for creative exploration, a medium for communication, and a catalyst for innovation. It's a process that's as much about the journey as it is about the destination. Prototypes are the language through which creative minds communicate and explore. In the hands of an innovator, the right tools can bring any idea to life. Let's talk about the many tools and techniques that bring prototypes into existence. From the humble pencil and paper to the cutting-edge 3D printers, each tool carries its unique potential and purpose. Starting with traditional crafting materials, you've got everything from cardboard and clay to wireframes and wood. These materials are great for quick, hands-on construction of physical prototypes. They're easy to use, inexpensive, and perfect for creating low-fidelity models during the early stages of design. Moving up the technology ladder, we find 3D printing. This marvel of modern tech allows for precise and detailed prototyping, capable of bringing high-fidelity models to life. Whether it's a small gadget or an intricate architectural model, 3D printing makes it possible to hold your design in your hands, examine it from all angles, and test its physical properties. But what if your idea is more complex, or perhaps not physical at all? That's where digital prototyping tools come into play. Computer-aided design software, or CAD, allows innovators to design and manipulate 3D models on a screen. CAD is versatile, offering an array of features for creating, editing, and analyzing designs. Virtual and augmented reality technologies take digital prototyping a step further. They create immersive environments where innovators can interact with their designs in a realistic, three-dimensional space. This is particularly useful when designing products or environments intended for human interaction. And let's not forget about software prototyping tools. These are essential when designing digital interfaces, apps, or other software products. They allow designers to create clickable mock-ups that mimic the functionality of the final product, enabling user testing and feedback even before the first line of code is written. Finally, there are simulation tools, crucial for prototyping complex systems. They can model anything from the flow of traffic in a city to the behavior of an ecosystem, or even the dynamics of a galaxy. The choice of prototyping tools is as diverse as the ideas they help to manifest. Every tool has its place in the creative process, and the key is to choose the one that best serves your design needs and brings your vision to life. Success often comes to those who prototype. This statement rings true across various industries, whether it's the tech world, automotive industry, or even fashion. Let's delve into a few case studies where prototyping played a pivotal role in development. Consider the Mars rover, a masterpiece of modern engineering. The journey from initial concepts and models to the final design that landed on Mars was not a straight line. It was a series of prototypes, each one an improvement on the last, based on testing, feedback, and meticulous refinement. This iterative process allowed engineers to work out the kinks, make necessary adjustments, and ensure that the final product could survive the harsh Martian environment. Then we have the heart valve replacement, a life-saving medical device that's transformed cardiac care. The prototype for this device underwent numerous iterations, each one a response to the challenges identified in the previous version. The result? A device that's safe, effective, and has saved countless lives. But prototyping isn't just about creating physical products. It's also crucial in the digital realm. In the world of software development, prototyping is used to create initial versions of applications, allowing developers to test functionality and usability before the final product is launched. Let's take a step back and reflect on these stories. What lessons can we glean? Well, for starters, prototyping is not a one-time event. It's an ongoing process, a cycle of creation and refinement. It requires patience, persistence, and a willingness to learn from mistakes. It's about embracing the unknown, venturing into uncharted territory, and being prepared to change course when necessary. Secondly, prototyping is a team effort. It requires input from various stakeholders, from engineers and designers to end users. Everyone's feedback is valuable in shaping the final product. Lastly, prototyping is a tool for risk management. It allows us to identify and address potential issues early on, reducing the likelihood of costly mistakes down the line. So remember, prototyping is not just a step in the process, it's a journey of discovery and refinement. It's about turning ideas into reality, one prototype at a time. At the heart of every great product lies a deep understanding of its user. This statement is the cornerstone of user-centered design, a philosophy that places the user's needs, preferences, and perspectives squarely in the center of the design process. Prototyping is a critical tool in this approach, allowing creators to explore and validate their ideas in a tangible, interactive way. Why is prototyping so crucial in understanding and meeting user needs? Well, prototypes offer a real, tangible representation of an idea, a concept, or a design. They provide a platform for users to interact with, to experience, and to provide feedback on. This interaction generates valuable insights that can guide the design process, revealing what works, what doesn't, and what could be improved. Think of it this way: prototyping serves as a bridge, connecting the abstract world of ideas with the concrete world of practical application. It's a tool that helps us translate our creative visions into something meaningful and useful for the end user. While prototyping can illuminate the path to success, it's not without its obstacles. And that's what we'll be exploring in this segment. One of the most prominent challenges in prototyping is resource constraints. Time, cost, and materials can all act as limiting factors in the process. Developing a prototype, especially a high-fidelity one, can be a time-consuming endeavor. It requires not only the time to build the prototype itself, but also the time to test it, gather feedback, and make necessary adjustments. The cost is another significant factor. Prototyping materials, especially for physical models, can be expensive. The use of advanced technologies such as 3D printing or virtual reality for prototyping can also add to the cost. Not to mention the labor cost involved in creating and refining a prototype. Material constraints can also pose challenges. The materials used for a prototype may not always accurately represent the materials intended for the final product. This can lead to discrepancies in the prototype's performance, which may not be evident until the final product is produced. Then there's the delicate balance between fidelity and functionality. At what stage should a prototype mimic the final product in detail, and when should it merely focus on functionality or a specific feature? This balance can be tricky to strike. High-fidelity prototypes can provide a detailed understanding of how the final product will look and function, but they're more time-consuming and costly to produce. On the other hand, low-fidelity prototypes are quicker and cheaper to make, but may not fully represent the final product's functionality or aesthetics. And let's not forget about the limitations of prototyping in accurately simulating real-world conditions or biological processes. For example, a prototype of a vehicle might not behave exactly as it would on real roads under varying weather conditions. Similarly, a biomedical prototype might not perfectly mimic the complex biological processes of the human body. Despite its challenges, the value of prototyping in the creative process is irrefutable. It allows innovators to visualize, test, and refine their ideas, paving the way for successful and effective final products. Even though it's not a perfect process, prototyping remains an indispensable tool in the world of design and engineering. As we look to the future, the prototyping landscape is set to evolve in exciting ways. Emerging technologies are poised to revolutionize how we prototype. Imagine a world where virtual and augmented reality become commonplace in design studios, allowing creators to manipulate and refine their prototypes in real time in a fully immersive three-dimensional workspace. Picture advanced artificial intelligence systems that can predict potential design flaws before a physical model is even constructed, saving countless hours of trial and error. Consider the possibilities of nanotechnology, enabling us to create prototypes at an atomic scale, pushing the boundaries of what's feasible in fields like medicine and electronics. But as we embrace these exciting new tools, it's essential that we also consider the environmental impact of our prototyping processes. The principles of sustainable prototyping encourage us to minimize waste, use resources responsibly, and consider the life cycle of our prototypes from inception to disposal. We must look for ways to incorporate recycled materials into our prototypes and strive for energy-efficient production methods. Digital prototyping tools can help us reduce the physical resources we consume while still allowing for effective testing and refinement. And as we move towards a more sustainable future, the importance of biodegradable materials in prototyping cannot be overstated. These materials allow us to create without contributing to the growing problem of plastic waste, and they open up new possibilities for sustainable design. We must also bear in mind that while these advancements can greatly enhance our prototyping capabilities, they don't replace the need for human insight, creativity, and judgment. Prototyping will always be a deeply human process, one that requires us to imagine, to experiment, and to learn from our mistakes. In the ever-evolving journey of creation and innovation, prototyping remains our most trusted compass. As we navigate the uncharted waters of the future, it will continue to guide us, illuminating the path from idea to reality. It's an exciting time to be a creator, and we can't wait to see where this journey takes us next.